In this video, I'll be reviewing the corresponding parts of congruent triangles are congruent, or CPCTC. This stands for that acronym, and when two triangles are congruent, we'll know that all their corresponding parts must also be congruent. But you need to remember that you can only use CPCTC after you've proved that the triangles are congruent. So we need to first be able to use one of the theorems we've learned, like side, 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 or side, angle, side, or etc., to prove the triangle's congruent. Once you know that the two triangles are congruent to each other, then we can say that, well, if this angle was corresponding with that angle and these two triangles are congruent, then those two angles must be congruent to each other because of CPCTC. So when we look at these two examples here, they're asking us which triangles can you show are congruent in order to prove the statement. So if I look at this picture, it's asking me to prove that angle P is congruent to angle H. So I need to somehow determine that these two are congruent. Well, first I'm going to have to state that the two triangles are congruent. So looking at this diagram, I'm going to try to decide which theorem could I use. I notice that I have a right angle here, which must mean that this angle is also a right angle. So I'm dealing with right triangles. When you deal with right triangles, you can always ask yourself, will Hypotenuse Leg Theorem work? When I notice that the hypotenuses are congruent, then I'm just looking for another leg. And by reflexive property, we could say that VS is congruent to itself. So now we have enough information to use the Hypotenuse Leg Theorem here. And that will give us the ability to say that triangle SVP is congruent to triangle SVH. So now that I know those two triangles are congruent, by CPCTC, I can say that angle P must be congruent to angle H because these are congruent triangles, so their corresponding parts must also be congruent. So similarly, in the next example, we're being asked to figure out whether, or to prove that angle D is congruent to angle F. So looking here at angle D and angle F, we first need to find two triangles by one of our theorems that makes these congruent. So I have a side DE that is congruent to the side FG. I also have angle E being congruent with angle G over here. So I will always want to look for reflexive sides, and we have EG congruent to itself. So this is enough information for us to see here that the side angle side theorem will make these two triangles congruent to each other. So that would mean that triangle DEG is congruent to triangle FGE. And we're doing it in that order because we're starting with the yellow corners here, putting the congruent angle E and G in the middle there, and then that last vertex of each triangle is the letter we didn't use yet. So that would mean that because D is the first letter of the triangle name that is congruent to F of the first letter of the second triangle, then those are corresponding parts, and they must be congruent to each other because we've proven that these two triangles are congruent to each other by side angle side. Similarly, back here, P and H were corresponding angles, and when we proved that those two triangles were congruent, we would know that those two corresponding angles are congruent to each other. So we proved it first that the two triangles are congruent, and then we can use CPCTC to say that their parts are also congruent. So we're going to give this a try in this proof. It says that given the side HI is congruent to the side HK, and the side IJ is congruent to the side JK, then we need to prove that angle IJH is congruent to angle KJH. So those are those two yellow angles right there. So looking at this, we so far know that two sides are congruent. Well, we either need to somehow prove that an angle between them is congruent or a third side is congruent. The easier way to see this, I think, is going to be to mark that reflexive side, HJ, is congruent to itself. So that's going to give us enough information to prove these two triangles are congruent by side, side, side. So looking here, our first statement was given. I'm going to leave this one blank and then look at the next part. I'm saying that these two triangles are congruent to each other. Well, when we marked up our diagram, that was because of side, side, side. So that must mean that that middle step that was completely blank will have to be our reflexive step that we drew onto our picture. And I'm going to state that HJ is just congruent to itself because of reflexive property. So then, now that I've proven that these two triangles are congruent to each other by side, 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 then their parts must be congruent to each other. So the corresponding parts of congruent triangles are congruent, CPCTC, is our final reason that this angle here must be congruent to that angle there. So because they are congruent triangles, their corresponding parts will also be congruent. In the next section, I'm asking you to recall what are the ways that we can prove lines parallel. So something that we learned were the angle pair theorems between parallel lines. And we talked about how if you have parallel lines and you have a transversal running through, if the angles are congruent, then the converse of, say, like the alternate interior angles theorem would prove that lines were congruent. So, or were parallel, excuse me. So a lot of these converses of angle pair theorems were how we did that. So we're going to use those converses to kind of help us, and CPCTC is going to lead us to using the converses to prove lines parallel. So once you prove that triangles are going to be congruent, then we'll have enough information to use CPCTC and the converses to say that the lines were parallel. So what I mean by that is we are going to try this proof here. So given that the side AE and BD bisect, so these two lines are bisecting. Well, we know that if lines are bisecting, then they're being cut in half. So that allows us to make the statement that AC is congruent to CE. That's down here, so that would just be the definition of bisectors. And then we could give the same reason for why BC and CD are congruent. So since those lines were bisecting each other, then that definition is just enough information for us to say that those will be congruent to each other. All right, so then on this other part of our picture, we can mark this up a little bit before we continue on. I have two triangles and they're across from these intersecting lines. Remember, whenever lines intersect, they create vertical angles, and vertical angles are always congruent. So that means that we can make the statement that the angle ACB must be congruent to the angle ECD because of the vertical angle theorem. We also did not mark that this was given, so we're going to go back and add that. So I've drawn this whole picture. I've marked my sides that were congruent because of bisectors, my vertical angles, and I noticed that I have a side, another side, and the angle between them that are all congruent. So that means that these two triangles must be congruent to each other by the side angle side triangle congruence theorem. So we've now gotten to a point where we've proven these two shapes are the same. So if the shapes are the same, then their corresponding parts must also be the same. And that's where CPCTC comes in. So we can make a statement about one of these angle pairs or one of these sides that will also be congruent that are going to help us mark that AB must be parallel to DE. So we're ultimately trying to prove that this side, AB, that line is parallel to this line, DE. If we're able to prove that those lines are parallel, then we'll have finished our proof. So using what we remember about parallel lines, we learned all about the angle pairs and their transversals. So if I consider that this might be the transversal between those parallel lines, I can start marking some of my shared angle pairs here. This angle right here would be an alternate interior angle with this angle. So if those two angles are alternate interior angles, and if they're congruent, then I would know that those lines are parallel. Well, using the corresponding parts of congruent triangles, I know that angle A corresponds with angle E. And I've already proven that those two triangles are congruent. So that is enough for me to say that the angle BAC is congruent to the angle DEC by CPCTC, or because they were congruent or corresponding parts of congruent triangles. And now that I've marked those with my potential parallel lines and I can see that they are alternate interior angles, then I'm going to use the alternate interior angles theorem converse to say that those lines must be parallel. If you have congruent alternate interior angles, then the lines must be parallel. The original theorem states that if the lines are parallel, then alternate interior angles must be congruent. So we're taking the reverse and saying, well, we know these angles are congruent, so the converse tells us that these lines must have been parallel.